So this is really a linear motion type question, and the mean value theorem part doesn't really come in until really you get to B and C. So let's take a look at this real quick. So it says, if a rock is dropped from a height of 100 feet, its position after it is dropped until it hits the ground is given by this function right here. So the first thing I want to unpack is when I read this guy, it says if a rock is dropped. When I see this word dropped, I can deduce a couple of things from it. The first thing I can deduce is that we are not throwing the ball up in the air, or we're not throwing the ball down to the ground. We're literally just holding it out and then letting it go. Okay. So what that to me means is the initial velocity V of 0 is equal to 0 because I'm dropping it. If I threw it down at 10 meters per second, then I think the initial velocity V0 would be -10. If I threw it up at 10, I think it's feet per second, sorry, then my initial velocity would be +10 feet per second. It's positive if it's going up, negative if it's going down. But in this case, it's just 0 because we're just dropping it. The second thing I would notice is that when they say it's dropped from a height of 100 feet, they're telling me that S of 0 is equal to 100. In other words, the initial height is 100. And we can really see that when we look at this S of t position function, right? If you put in a 0 for t, you would get 100 popping out. So that kind of matches here. Okay. So in this question, they say determine how long. So how long, to me, that means we're looking for time. And when it says before the rock hits the ground, when I see the rock hits the ground, to me, that means when S of t is equal to 0. So all we're going to do is we're going to take this S of t and set it equal to 0 and solve for t. So this guy becomes 0 equal to -16t squared plus 100. This means 16t squared is equal to 100. This means t squared is equal to 100 over 16, which means t is equal to plus or minus square root of 10 over 4, which is square root of 5 over 2. Ran out of room somehow. Hold on. Let's get daily occurrence. So we can slide this over. And I wanted to include my units, that's seconds. So that's going to be how long it takes. Now, technically you have plus or minus, right? But we don't allow negative time. So that's why I say I want to take the positive form. When you see, let's look at part B. When I see the words average velocity.
Professor,
yes?
I think we should remove the square root because you already.
Oh, thank you. You're absolutely right. Sorry. And hopefully I would have seen that sooner, but I took the square root already, so I don't need to I don't need to write that in there. So thank you for sure. When we talk about average velocity, anytime I see the words average velocity, I'm thinking about the slope of the secant line. Remember, the average velocity is the slope of the secant line, and the instantaneous velocity is the slope of the tangent line. So, and the mean value theorem kind of relates those two things together. So for this question, we basically just want to calculate the average velocity. So the V average is going to be equal to the position function at some time minus the position function at some other time divided by their corresponding t values. So this guy looks like a slope. And the question is, what are those 2 points, A and B? And when I look at this, it says from when the rock is released and the rock hits the ground. So when the rock is released, I think the point that we're going to have is going to be 0, 100, because you drop it at time 0 and that initial position is 100. When the rock hits the ground, the x value there, or the time, not x value, sorry, the time value there is going to be 5/2. That's what I just found. And its position is going to be 0 because it's on the ground. So we just plug in those numbers. So the y value is 100. That looks too much like infinity to me, but it's not. It's 100 minus 0 over 0 minus 5/2. So you got to make sure that your x values and your y values are matched up correctly. So when we do that, what do we get? We get 100 over 5/2. We know that dividing by a fraction is the same thing as multiplying by the reciprocal. So it's like 2/5. That's 200, or it's -2, right? It's negative. And that's going to give you a -40 feet per second. Now, does it make sense that it's negative? It does, because the rock is going downwards. Does that make sense to everybody? Is there any questions? So the last part of this guy says, find the time t guaranteed by the mean value theorem when the instantaneous velocity of the rock is equal to this average. Oh, they put a G there. Fine, I'll put a G too. That looks ugly. AVG. All right. So I know what the average velocity is. That's -40. I know how to find the instantaneous velocity. When I see the words instantaneous velocity, I immediately think F prime. So what we want to do is we want to find F prime of C equal to -40. We want to find C, I should say, such that that's true. Does that make sense to everybody or not? So this is the average velocity right here. This is the instantaneous velocity. We want those two things to be equal. We want to find the C that makes that work. So the first thing I'm going to do is I'm going to take the derivative of F. Our F is actually the position function. So maybe I should change that F to an S like this. And we know that S of t is equal to -16 t squared plus 100. This means S prime of t is equal to -32 t. This means that S prime of C is equal to -32 C. And I want to set that equal to 40. So if I have -32 C equal to 40, that's going to give me that C is equal to -40 over 32, or negative
5/4.
No, sorry. I was wondering why my answer was negative, and then I realized that I put 40 instead of -40. So there has to be a -40, right? I forgot the negative. So a negative divided by negative gives you a positive. So this would be plus 5/4, as you said, Reagan. And the units are seconds. Okay. All right, cool. So so we have a couple of theorems.
Professor,
Yes,
could you just scroll for like half a second?
of course.
That's good. That's I'm fine.
All right, cool. Aram, I wanted to tell you something. You didn't upload your test properly.
Really?
You uploaded 2 of the pages. The good news though is I had your paper copy and you did really well on the part that you didn't upload anyway. So,
Okay, that's fine.
good job. In the future, if you could upload it properly, I'd be happier. But I'm ultimately happy that you did well. So that's the main thing.
Thank you.
Let me tell you what these corollaries are. I guess, the first thing is that if f is a differentiable function on an interval I, and if we have that f prime of x equals to 0 for all x in that interval, then f of x is constant on that interval. To me, this seems kind of obvious. If you have a prolonged period of points where the tangent line is horizontal, that means that that segment of the function is going to be a horizontal line or a constant function. The second corollary is pretty much very related, which says if f and g are differentiable functions over an interval I, and f prime of x is equal to g prime of x for all x in that interval I, then your two functions are basically going to be the same function. They only differ by a constant. Okay.